Hello everyone and welcome back. Now it's getting interesting. And the reason for this is we're gonna add our first impulse, um, impulse function to our physics engine. This episode we're gonna add a linear impulse, so no rotation, but this will change in I think. Well, yes, it's gonna take a little bit time. Before we're gonna add the rotation impulse, because before that we need to calculate inertia and do some other things, but we're gonna add the linear impulse today. So go to the manifold class, and here you see resolve collision and positional correction. And in the resolve collision, we're gonna add the code for our linear impulse. So I'm gonna make a comment here and say linear impulse. And the first step we need to do is calculate the relative velocity between two bodies. The relative velocity is basically you subtract one velocity from each other, then you have the relative velocity, the velocity like if you're on a highway and you're overtaking another car, these two cars, your car and the other car, have both a velocity, but if you only look to the other car, you are a little bit faster, or yeah, depends on how fast you're overtaking it, of course, but you are, from your perspective, you are a bit faster than the other car. And we're going to calculate this relative velocity here. So, yeah, relative velocity is equal to, we need to subtract one velocity from the other one. We're gonna say here this dot Richie B dot velocity. We can also say get velocity, but I'm gonna use this one. This dot which A dot velocity. That's the relative velocity. Now we're gonna calculate the relative velocity along our penetration normal. Okay, we need to get this value along our penetration normal, and that's quite easy. We just need to project the relative velocity onto the normal. And we can do this by relative velocity, by saying relative velocity a dot, and then we're going to say this dot normal. Okay, and then we have the velocity along the penetration normal. And of course I'm going to save that too, and this will be called relative velocity along normal. Okay. And I think we can also print this one. So I'm going to say this console log. And I'm saying velocity along normal is, yeah, just the relative velocity along normal. All right. If this value along the normal is greater than 0, then we can return. Don't go any further, because if the velocity is greater than 0, that means that the velocity, the bodies don't collide with each other. Let's take the example on the highway. It's like you're trying to overtake, but your velocity is lower than the other one. So you get further apart from each other, and that's the case in this one, in these lines. Okay, then we have to declare another variable, and this is the e variable. This is, when I remember correctly, the bounciness, but I'm not quite sure. Let me check. I'll be right back. All right, I was right. That's the restitution coefficient. Here we can use our material bounce attribute we declared earlier, and also we're gonna calculate this one later, like in the next episode, or maybe at the end of this episode. But yeah. We were gonna set it to 1, so the collisions, well, the objects of the collision will not lose any energy. If we set e to, for example, 0.5, then the objects will lose half of its energy after the collision. Then we're gonna set j. J is our impulse. Yeah, it's our resulting impulse. This is also this is only a value, so no vector, and we can calculate it like this, and then we have to multiply this with the relative velocity along the normal, and then we can calculate our impulse vector. So our impulse vector is equal to this dot normal. Well, of course, scale the normal by the j value, and then we need to add it to our impulse. Well, we need to create 2 vectors, one impulse vector for Richie A, one impulse vector for Richie B, and we're going to scale it. So the impulse will be divided between those rigid bodies. So let's say impulse vector Richie A is equal to scale impulse vector by minus 0.5, and we can just copy this line, add it to the other one, and say this is positive 0.5, and this will be rigid body B. Okay, and now we can add this impulse vectors. So Richie A dot velocity is equal to, here also we can say set velocity. I'm gonna do it like this. Yeah, I leave it to you. Is this dot rigid body A dot velocity, and then here we're gonna say impulse vector Richie A, and the same thing for rigid body B. I'm gonna copy it again, say rigid body B. This will be also rigid body B, and this vector. All right. And here I'm gonna say, no, I'm not gonna say anything. And that's it for our linear impulse. Hopefully it does work. Let's see. Now we're gonna jump to the simulation class. Here we're gonna change again. Yeah, the whole full loop basically. I'm gonna remove the gravity force, the added one, and I'm gonna remove everything else except the update, rigid bodies update. Okay, then I'm gonna add another for loop. I'm just gonna copy the other for loop because we need the same content almost. And here I'm gonna say, I'm gonna copy that for loop again, and I'm changing the i's to a y. There we go. So we're gonna check every body against every other body, but not the same body with each other. So if I is not the same like J, then we get the rigid body A from the first for loop, and the rigid body B from the second one. There we go. Then I'm gonna do a collision detection with our method. I'm gonna save the collision manifold in a separate variable. Collision manifold is equals to collision detection dot check collisions, and this is Richie A and Richie B. Then I'm gonna say if there is a collision manifold, so if there is an actually if there is an collision, then we're gonna say collision manifold first positional correction. We got note that this method is still has no content, so there's nothing. It's not gonna do anything, but I'm gonna call it anyways. Positional correction. All right, and then our resolution step. Resolve collision. There we go. Okay, then I'm gonna change our rigid bodies we have in our simulation now. Yeah, I think I can leave one circle there. I think I'm gonna remove everything except this one circle. But no, I just leave it like this. Yeah. Then I'm gonna add a new rectangle. This dot rigid bodies dot push new rigid body. This will have a new rectangle shape. New rectangle. And the position of this one will be 600 and 600. The width is 200 and the height is 100 and the mass is 10. Then I'm gonna have another rectangle and the position will be 200, 600. That's gonna be a width of 100, so it's gonna be a kind of flipped rectangle, and yeah, a head of 200. That's it. And then I'm gonna change the rotation of the first rectangle, and I'm gonna do this by rigid bodies 0. I'm gonna call here the get shape function, and then I'm saying rotate by 1.3 radians, not degrees. It's gonna be radians. All right. Okay, it's not working. Let's see why a vector is not defined. Okay, yeah. I have to write here a vector 2. Okay. Jump back, and there we go. We have another error in the update. Reference error B is not defined. Simulation 23. Oh, yeah. Of course. I don't know how I did that. That must be a J. Okay. Then let's refresh again. Okay, it's working. Cool. Now, okay, I have the circle now in my control, but I'm gonna change the force here to 5000 because it's a bit tedious to do that by hand, like this. Okay, refresh. Then with the arrow keys, I'm gonna move my rectangle into the circle shape, and let's see what's happening. Okay, no collision. And let's see what's happening with the other one. Okay, yeah, there's something wrong, I guess. I'm gonna check and see you in a short second. Okay, welcome back. I found the error. What I did first is I rotated the wrong shape. I want to rotate the one at the first. Yeah, at the first. Well, actually, at the second element of the array, so that the rectangle you see here is rotated. What I did is changed this one from 0 to 1 and rotate it by 1.3. Okay, and why we don't have a collision? The collision manifold is null. The reason is obviously quite simple. And yeah, we are checking here if the shape is a circle, but I'm passing the rigid bodies. So what I need to do is passing the actual shape of the rigid bodies. Yeah, I'm gonna rename this here to Richie A. So I'm gonna so I can pass a rigid body, and I'm gonna say that the shape, let shape A, is Richie A dot shape, and the same thing for shape B, Richie B dot shape. There you go. And now it should work, hopefully. So we go back to the browser, refresh. Now I'm gonna move this rectangle here and throw it into the other rectangle. See what happens. There we go. We have another arrow. Collision manifold positional correction. Position correction is not a function. Ah, okay. Yeah. I spelled that wrong because it's called positional, not position correction. So I'm just gonna copy the name of the function and paste it in here. And there you go. Let's try this again. Go back to the browser. Hopefully it works, and it still doesn't work. And this time, uncode, type error, cannot read properties, undefined reading velocity at collision manifold, just 12. Okay, let's see. There. Okay. Yeah. I also forgot something else, and this is we need to actually set the rigid bodies to the collision manifold too. Okay, so let's add that. In the collision manifold, say Richie A is equal to null, and this dot Richie B is equal to null too. Okay. And then, of course, we need to set it in the collision detection class here. And I'm gonna say that before the return statement, that if the collision manifold is not null, I'm gonna say collision manifold Richie A is equal to Richie A, and then collision manifold dot Richie B is equal to Richie B. And now we set the rigid body to the collision manifold too, and now we can actually use the methods in the resolve collision and positional correction. And hopefully it will work now. Oh, let's see. And okay, it's working, but the collision doesn't work. Okay, let's see what's going on here. All right, there were two errors more. First of all, I changed this one. It was smaller, must be greater. And there was a spelling error. I think it was this scale here. It was like this, and I changed it like this. Okay, now go back to the browser again, and now it's working. There we go, we have our collision. Same thing for the circle. Same for the circle. There we go, there's our collision. I'm gonna change the velocity damping so we can see more. It's not gonna, you know, slow down our velocity. So let's refresh. I'm gonna aim a little bit to the left. Then we should see that the circle here is going like to this direction, somewhere there. So let's try. And there we go. It works. Awesome. This one was working too. Nice. Ah, okay, that's the circle. No, okay, I missed it. All right. After some problems, we finished the linear impulse episode. Yeah, I hope that was okay. I did some errors here and there. Yeah, but I don't think you can prevent that with serious editing. Well, anyways, it's working now. I hope you had some fun. See you in the next episode. In the next episodes, I'm going to show you how we can add a weight to the shapes, so that a shape with like a mass of 100 is a bigger impact than the shape with just 10, you know. Yeah, then after that we're gonna add some kinematic bodies, so these bodies won't move, basically. Then we're gonna add boundaries and the gravity again, adding the bounciness back too. Finally, we're gonna add the positional correction, and I think then one of the most annoying parts I had in the past to find the right one is calculating the inertia for any convex polygon. And then we're gonna implement our rotational impulses and our frictional impulses, and then we can say we have a kind of finished physics engine with the basic things. After this, we're just gonna add some features, and yeah. So it's getting interesting in the next couple of episodes. Hope you're excited, like me, and yeah, I'll see you in the next one, and have a nice day. Bye bye.